Now that we have learnt all types of premature beats and escape beats, let us proceed to various rhythms arising from the SA node, atria and ventricles. Abnormalities in SA node rhythm may be in the form of sinus arrhythmia, sinus bradycardia and sinus tachycardia. Sinus arrhythmia. Normally, the heart rate increases slightly during inspiration and decreases during expiration. This variation is termed as sinus arrhythmia. Sometimes the variation may be so marked that it may be confused with pathological arrhythmias. In this ECG, which is a continuous strip, the RR interval varies from 16 small squares in expiration to 22 small squares in inspiration. But you will note that all PQRST complexes are normal. Each QRS complex is preceded by a P wave with fixed PR interval. This indicates sinus rhythm. So now we know the features of normal sinus rhythm. Number 1, the P wave morphology should be normal. Number 2, the PR interval should be normal and constant. And number 3, each P wave should be followed by a QRS complex. In such a case, if the heart rate is below 60 per minute, that is RR interval is more than 25 small squares, it is termed as sinus bradycardia. In this ECG, the RR interval is 34 millimeters, so the heart rate is 44 per minute. P wave, PR interval and QRS are normal, indicating sinus rhythm. So this is sinus bradycardia. This is another recording of sinus bradycardia with heart rate of 33 per minute. The RR interval is 45 millimeters. Note the normal P waves and normal PR intervals. Sinus bradycardia is seen in athletes during sleep and with drugs like beta blockers. Sinus tachycardia. If the sinus rate is above 100 per minute and up to 150 per minute, it is termed as sinus tachycardia. In this ECG, the RR interval is 12 millimeters, so the heart rate is 125 per minute. The T wave and the next P wave are seen very close together. The practical problem that arises at high rates is that the P waves and the previous T waves mix up and P waves become difficult to identify. In this ECG, the RR interval is 10 millimeters, so the heart rate is 150 per minute. Now see the upper tracing of V5. It is very difficult to identify the P wave, but if you observe all leads carefully, the P waves are usually identified in at least one of the leads, as seen in lead V1 in this case. So careful inspection of all the leads for P waves becomes very important in tachycardias to identify a P wave.